We've already looked at making functions continuous. Now we're going to make them both continuous and differentiable. So if I look at my first example, we want to find a and b so that the function is continuous and differentiable. Okay. Well, we already know for it to be continuous, okay, you have to have the same y value. Okay, where this graph stops at x equals 1, this graph needs to pick up at the same place. Okay, so the first part is taking care of making it continuous. And I'll do that by setting the y values equal to each other, which is just the f of x value, the function value. So we have ax squared minus b equals x cubed minus 2ax. Okay. Now to make it differentiable, that means it has a slope. Okay, so in order to make it differentiable, I need the slopes to be equal, which we always get the slope from the derivative. So now the second part, I left the u off of continuous. Okay. So now to make it differentiable, I'm just going to set the slopes equal to each other. So I need to take the derivative. So this will be 2ax to the first. B is just a constant, so that's going to go away. When I take the derivative, it'll become 0. The x cubed will become 3x squared. This is x to the first, so that will be minus 2a and then x to the 0, so no x's. Now to solve this, I am just going to take my x value from the inequality, which is x equals 1, and plug it in for all my x's. So 1 squared is 1 times a is a, minus b equals 1 cubed is 1, minus 2a times 1 minus 2a. Okay. Now when I have two variables in my equation, I'm going to move all my variables to one side. So move the 2a. That'll give me 3a minus b equals 1. Then I'm going to jump over to the slopes equation, plug in 1 for all my x's. So 2a times 1 is 2a. X squared is 1 times 3 is 3 minus 2a. Now this equation only has a's, so I'm able to solve this equation, and then I can take my a value, plug it in over here. So I'm going to add 2a, that'll be 4a, equals 3, divide by 4, and I'll get a equals 3/4. Then I can take this a value, plug it in right here, so 3 times 3/4, that's 9/4, minus b equals 1. Okay. So I'm going to move the b over, subtract the 1, so that will be 9/4 minus 1, which is 4/4. So that will give me a b value of 5/4. Now let's look at another one where we're going to have to use a system to solve the equation. Okay. So again, to make it continuous, I'm going to set the two functions equal to each other. So ax cubed minus bx is going to equal 2x minus a. Then to make it differentiable, I need to set the slopes equal to each other. So this will become 3a and then an x squared minus, that's x to the first, so 1 times minus b is minus b, x to the 0. Then 2x will just be 2. A is a constant, so when I take the derivative, it's going to become 0. Okay. Now that I have my two equations, I'm going to look at my inequality. So where we need to make it continuous and differentiable is at x equals 1. So plug in a 1 for all your x's. X cubed is 1 times a. B times 1 is b. 2 times 1 is 2 minus a. And then I'm going to move the a over, get all my variables on one side, leave my constant on the other. Then I'm going to jump over here. So plug in 1. That's 1 squared is 1 times 3a is 3a minus b equals 2. So in both equations, I have an a and b. So I'm going to have to use elimination to solve. Okay. I'm going to go ahead and eliminate my b's since I have negative b's on both of them. So that means I just need to take one of my equations, multiply through by negative 1. So that'll give me negative 2a plus b. I'm going to line it up with my other equation over here. And then negative 1 times 2, negative 2. Okay. So I've eliminated the b's. 3a minus 2a, that's 1a. 2 minus 2, 0. So we get a equals 0. Okay. And now I can pick either equation and plug it in. I'm just going to jump back to this one right here. So 2 times 0 is 0. So that's going to leave me with a negative b equals 2. Divide by a negative 1. We're going to get b equals negative 2. Now let's look at one last one with some trig functions in it. So my first part, to make it continuous, I'm going to set the y values equal to each other, which would be 2 sine of x equals ax plus b. Then my second part, to make it differentiable, I'm going to set the slopes equal to each other. So the derivative of 2 sine is 2 cosine of x. The derivative of ax is just going to be a. B is a constant, so it'll go away. Okay. Then I can plug in pi over 2 for all of my x's. So this will give me 2 sine of pi over 2 equals a times pi over 2. That'll just be pi over 2a. Okay. I can go ahead and evaluate sine of pi over 2. So pi over 2 is over here on the top of the y-axis. Okay. Sine always goes with your y value. So my y value is 1. So this is 2 times 1 equals pi over 2a plus b. And then I'm just going to simplify my 2 times 1, make it 2. Okay. And then I cannot solve this equation yet since I have 2 variables. So again, I'm going to jump over to my second one. I'm going to plug in pi over 2. Okay. And this one will allow me to solve for a. So now I need to find cosine of pi over 2. Cosine goes with your x. If I look at pi over 2, my x value is 0. So I get 2 times 0 equals a, and 0 times anything, just 0. So now that I've got a, I can plug it in over here. So pi over 2 times 0, just 0. And I can solve and get b equals 2.